Okay, so looking ahead, or well, actually, a quick note. I left off in the last video. It was cut off as I was talking about statistical inferences that are taking place when our blood is being drawn to test for cholesterol, and wanting you to think about that. For example, it being a representative sample, cholesterol being well mixed throughout your blood, right, etc., etc. So, going forward from there, right, we want to talk about confidence intervals for just a minute. In other words, measuring how confident we are, all right, in our statistical inferences and our analyses. So consider the following quote. A poll shows that Arnold Schwarzenegger will receive 46% of the vote with a plus or minus 3% margin of error. We see that sort of language all the time, but what does it really mean? Right? Well, we know it means, all right, 3% margin of error, meaning 43 to 49. Right, so his actual percentage, right, must fall between there, or is likely to fall between there. Okay, so because of the uncertainty of reality, right, what it means to us mathematicians is that our sample size, along with things like our sample was well representative of the entire population, our methods of collecting the data were appropriate, right, or unbiased, but it means the sample size was sufficiently large in our polling that the actual percentage of Schwarzenegger voters is likely to be within their 43 to 49% of the total. Okay. Now, this language of is likely to be is important, okay, because that again says is likely to be. There's some uncertainty. In other words, how likely? Okay, so typically this is given at a 95% confidence level, meaning that the analysis is such that we are 95% confident that Schwarzenegger's vote total is going to be between 43 and 49%, right? That 95 isn't just pulled out of thin air, all right? In other words, if you remember statistical significance and p-values, all right, p-value, right, p less than or equal to 0.05, right, or 5%, right, 95% is that complement there, okay? So there are different levels of confidence. Okay? If we use a 95% confidence interval, then we're saying again there's only a 5% chance that we would select a random sample of our size, right, whose proportion of Arnold voters would differ by more than 3 percentage points from 46%. Okay, there's only a 5% chance that a random sample would end up outside of our confidence interval. Okay, and I'm using that language, so I better say it. The range 43 to 49% is called the confidence interval. Okay, go ahead and take a second and rewind that. I said that very quickly if it didn't hit home. Okay, but looking at different levels of confidence, we could also require a 99% confidence interval, meaning we'd want to be 99% confidence that the actual value, right, would be inside whatever interval we give. Okay, so there's a question in your assignment getting at that sort of that idea of the different confidence levels of confidence. So in trying to, since we used an example of polling, I want to say something about it. In trying to estimate the percentage of a population who favor a certain candidate, the estimated margin of error depends on the size of the sample. Specifically, for 95% confidence, a sample size n will have a margin of error approximately equal to 1 over the square root of n. Okay? If we were in a statistics class, we'd be a little more precise than that, but it's a good approximation for our purposes. Okay, so for a 95% confidence interval, we've got a sample size of n, right? The margin of error should be 1 over the square root of n. Okay? So I want to make a note about this. Is the actual global population, the total population of whatever data we're collecting, is that involved in the computation for margin of error at all? No, right? And so the reasoning we might say that is because think of chicken soup and blood cholesterol, right? Or let's just look at chicken soup for a second. If you are making 10 gallons of chicken soup, right, and you mix it well, and you're going to taste test it for the saltiness of your soup, right? My question is, if you've got a one pot, like a gallon pot, of chicken soup, and then you've also got a 40-gallon pot of chicken soup, and you're mixing them both, and you're wanting to test them both for salt, their saltiness, okay? do you take a spoonful out of each of them? Or do you take a spoonful out of the 1 gallon and 40 spoonfuls out of the 40 gallon, right? The idea is you would take the same, right, sample size to test for saltiness. Well, likewise with our polling, for example, the margin of error really depends on your sample size, all right? And so we can look at it as sort of free from the global population, right, for our purposes. Okay. So down here there's a calculation, I give an example for 1,200 people, and just going through and applying this sort of, or the computation for margin of error. And from here, there are added notes here to help you if you need help walking through the assignment. But I'm going to upload a video talking about the assignment a little bit.